So we're going to look at this equation, and we need to talk about the translations. So the translations are just how it moves. So what do we know about the 5? Where's the 5 located at? Okay, the 5 is located on the end, right? And what do we know about numbers on the end? Numbers on the end either move it up or down. So this 5 is on the end. It is positive. So what's that going to do to my graph? Okay, that's going to shift my graph up 5 units. So let's look at our choices. Which one's it going to be? Is it going to move it 5 units to the right? No. Is it going to move it 5 units to the left? Nope. 5 units down? No. So what does it have to be? D. Right? We're moving it up 5 units because that 5 shifts that graph up 5 units. And we can add more to the list if you find some more, but I figured that this was at least a good start for us. Now, question 7, we need to graph it. Okay, so if I want to graph this, what's the first thing we do? Well, it's a step-by-step procedure. The first thing I like to do is figure out what is the graph going to look like. So I go back and I look at the operation. What operation is around that x? It's a square. Okay, it's x squared there. So since this is a square here, what is my graph going to look like? In a way, it's going to resemble that, right? So it should look like this. Is everyone okay with how I did that? I looked at it and I said, it is a square. Okay? Square makes a U. When you take your exam, you can use the back cover of your textbook. So you don't have to memorize them all. So I notice it was a square, so it makes a U. Then we go and we look at it, and I like to start at the back and work my way forward. So what does this 2 do? Well, the 2 is on the end, up and down. It is a positive 2, so what does that do to it? That moves it up 2 units, right? Now, be careful with the number inside. The number inside is a 1, and it is positive. I always remember it's the opposite of what you think it should do. So you would think it's positive 1, so we would move it forward 1 unit. No, it's the opposite, so it makes it do what? Back 1 unit. That's the way I remember, is it's opposite of what you think it should do. That's the way I remember. What about the 3? Well, that's similar to your slope, but it's not. But it's going to be up 3 and over 1. 1. I'll give you a moment to think about and understand the translation. So I know it looks like a U. Why does it look like a U? Because it's squared. That's the first thing I did, was I identified the graph. So it's a U. Then I looked at the end. 2 makes it move up 2 units. The 1 is inside the operation, so opposite of what you think, so it moves it back 1. Now, with that in mind, where am I going to start at? Well, I'm going to start back 1 unit, so that makes it a minus 1. And how many units up? 2. So where am I going to start at? I'm going to start at minus 1, positive 2. So back 1 unit and up 2. Is everyone all right with that? Now, we know it's going to be a U opening up, and why is it going to open up like this and not down like that? Well, what's the number in front? 3. 3 is positive, right? So it's going to make it go up. Now, how does this work? We take our starting point, which is right here, and we go up 3 units. So 1, 2, 3, and we go over 1. So that makes my dot right there, up 3 over 1. And we curve it kind of like that. Now, how do we get the other side? It needs to make a U. Currently, we have half of the U. So we go back to our starting point, and we go up 3, and we go back 1. So that's going to make another dot right about there. And we curve it. So that's what my graph should look like. Is everyone okay with how I did that? It's actually a pretty easy concept to understand. Graphing these we didn't do a lot of algebra, not a lot of computations. It's just understanding the basic procedure. So that was 1 that we did. It was multiple choice, and I graphed 7 for you. Or sorry, I graphed 7 for you. So I'm going to leave 5 and 6 for you to work through. 8's very similar. Same thing with 9. I did pick 10 because 10 is that piecewise, or not piecewise, greatest integer function, right? So 10 is a greatest integer, which is the case of stairs. So let's see how we would graph question 10. First thing we do is we identify the graph, and this is called the greatest integer graph. And the greatest integer graph looks like this. It looks like a case of stairs. So similar to this. So we know it needs to look like a case of stairs. Now, one thing we have to remember with the greatest integer is where we start is going to have a closed circle. So very, very important. We always start with a closed circle. And this -1 is outside of the greatest integer bars. So it's on the back. So that's going to make it move down 1 unit. Is there anything inside with the x here? No. So it's not going to slide left or right any. It's only going to slide down 1 unit. So where are we going to start at? Well, we are going to start down 1 unit. So that's going to be at 0, -1. That is where we're going to start. Bless you. And where we start, we have to use a closed circle. So we start 0, -1. So that's right here. Down 1 unit. There is no number in front. If there's no number in front, we know there should be a 1 there, right? So that's going to be up 1 and over 1. And now we just fill in the dots. So we go up 1 and over 1 from my starting point here. Up 1, over 1, make a dot. Up 1, over 1, make a dot. Up 1, over 1, make a dot. And you can do some in the opposite direction too. You can go down 1, back 1, down 1, back 1 if you want. And what does it look like? Okay, the closed circles are always below. So we have a closed circle here, open circle below, closed circle, open circle, closed circles on the top, open circles below. And that's what it's going to look like. So it's a case of stairs, and what happened to it? It got slid down 1 unit. Is everyone okay with how I graphed that? Now, what's the key takeaway? Make sure that wherever you start has to have a closed circle. That's the important part. If this would have been negative here, if this would have been a -1, what would it do? It would be a case of stairs going down from left to right. Did we have any other questions from that 1 through 11? Out of 2, 6, and 7. Anything else? Now, we have not covered 12 through 15. We're going to look at those right now. So if you don't have any other questions, then we're going to go ahead and look at 12 through 15. And these are called piecewise defined functions. They are called piecewise defined functions because they are done in pieces. So this is still 2, 6, and 7. And this is going to be for homework. Questions 12 through 15. Okay, so this is going to match up with your homework questions 12 through 15. Now, these are piecewise defined functions. It says in the name, piecewise defined. So that means we're going to have to do it in pieces or parts. So these are discontinuous functions, and they have to be done in pieces. Okay, there are different pieces or levels, and we need to determine how to either find the value or graph the function. So I'm going to start off with evaluating these. So I'm going to use the same directions as our homework. That way we don't get confused. So we're going to find the requested value. Okay, so I'm going to find the requested value. I'm going to give you a function, and let's say f of -2, and you're going to do this for, how about, we'll do one that has 2 levels. F of x equals x minus 5 and 8x. And let's say this one is if x is about less than or equal to 0. And let's say for this one is going to be if x is greater than 0. Okay, now, what we need to do is we need to find the answer. Now, we are only going to get one answer. We have 2 different levels. Level 1 and level 2. We are going to plug in -2. Now, we need to look and see what we have. And let's talk about what goes with each level. So, level 1 here. Level 1 is if your values of x are less than 0. Level 2 is going to be for values of x that are what? Greater than 0. And this is my x here. So, which one would it plug into? 1 or 2? Can anyone tell me? Row 1 or row 2? Which row would I use? And why? Let's make sure we know. What does this one say? Row 1. This says if x is what? Bigger than 0, right? Or sorry, less than 0. This was less than 0. Less than or equal to 0. This one is for numbers that are what? Bigger than 0. Now, what about my -2? Where's -2 at? -2, right, is less than 0. So since -2 is less than, you're going to use level 1. Less than 0, use level 1. And when I plug in f of -2, then what does it look like? I'm going to plug in -2 into level 1. And that's going to be a -2 minus 5, which then that makes it a what? -7. And that's it. Did I plug it into the second row? No. Why not? Because you need to figure out and determine what row it goes into. It doesn't go into both of them. Okay, it only goes into one of them. Let's do another one. We'll probably do 2 or 3 of these, and then we'll graph them. So again, same directions. Find the requested value. This one's going to have 3 different levels. let's say if x is, how about, less than or equal to 5. This one will be if x is between 5 and 10. And this one will be for x greater than or equal to 10. Okay, now, here's my levels. And let's talk about each level and what values go with it. Okay, so level 1, what does it say? It says if your x is what? Smaller than 5. That's what it says. Use row 1. Row 2, what does it say? It says if your value of x is between what? 5 and 10. What about row 3? If your value of x is what? Bigger than 10, right? So what are we looking at here? 9. So where does 9 go? It goes in here, right? Why does it go in level 2? Okay? So let's write that out just so we know. Since 9 is between 5 and 10, use level 2. Okay? So we don't plug it into all 3. It only goes into one of these. So it goes into level 2. And what would that be? So that would be f of 9 equals now 9 minus 9, which is then what? 0. One more, just to make sure that we understand these. Now, what's the most commonly made mistake? When I grade these homework, where students are most likely to make a mistake is they're going to try to plug it into all 3 of them. You only plug it into one of them. It's only going to apply to one of these equations here. So you look at your condition, you figure out which level it's on, and you solve it. Let's do one more. Let's find the requested value. And let's say f of minus 8 for f of x if, let's use, how about an x squared plus 1, if my x is, how about less than or equal to negative 12, how about we use a 2x minus 5 if x is between, how about negative 12 and negative 9. And let's use x squared plus 4 if x is greater than or equal to negative 9. So this is what we've got. We've got the 3 functions here. Now, we need to figure out which row we use. We only use one of the rows. This negative 8, well, that is your x value. So let's talk about the first row. Why is the first row not going to work? The first row is for values of x that are what? Less than negative 12. Is negative 8 smaller than negative 12? No. So that one doesn't work. What about the second row? It's for numbers that are between negative 12 and negative 9. Is negative 8 in there? No. What about the third row? What is it for? It is for values of x that are what? Greater than or equal to a negative 9. Does that apply to this one here? Yes. So, since negative 8 is larger than negative 9, you're going to use level 3. And so what would that be? If I plug in f of 8, negative 8 here, that would be negative 8 squared plus 4, and that's 64. plus 4, which is then 68. And that's it. The first two questions from this part, 12 and 13, those are find the requested value. Now, do not plug it into all three rows. You only plug it into one of the rows. For the next ones, we're going to be graphing these. And when we graph them, we plug points in. We plug values in, and we plot points. So we'll do one that has 2 rows, and then we'll do one that has 3 rows. So now we're going to be graphing these. And when we go to graph these, sometimes we use an open circle, and sometimes we use a closed circle. So greater than or equal to, less than or equal to, those get a closed circle. Strictly less than, strictly greater than, those get an open circle. So I'm going to give you a function, and we're going to graph this function. And this one has 2 levels. And I'll make it similar to what's in your homework. We're going to try to graph this. And this is very, very similar to question 14. So this is going to be like question number 14. All I did was I just changed the numbers around a bit. But it's very, very similar. So the first thing I do is I determine if they have an open circle or a closed circle. Bless you. So this one is x is greater than or equal to 3. So greater than or equal to, it gets a closed circle. And then the other one is less than 3, so it gets an open circle. And I'm going to label this 1 and 2 here. Now what we do is we need points. Right? We need 2 points because these are going to be lines. So we're going to get 2 points, we're going to connect them together and make a line. Now, it's 2 separate lines on the same graph, so they're done in pieces. So let's start with row 1, or level 1. The first thing we always do is we just plug our value in. So we're just going to plug in this 3. So we're going to plug in x equals 3 into row 1. So we'll plug in x equals 3 into row 1. And that's going to then be 4 times 3 minus 1, which is 12 minus 1, which is an 11. So my first point is going to be 3 comma 11. Now, to graph a line, what do we need? Oh, yes. And you might check, you might have some homework over there too. Some graded homework. You might check and make sure. Okay, so that's going to be our first point at 3 comma 11. Now we need another point. What does this one say? This one says x is bigger than 3. So we need another number bigger than 3. So how about we use 4? And we're still in row 1. We're going to use 4. And so what does that give you? That gives you 4 times 4 minus 1. So that is 16 minus 1, which is then what? 15. So my second ordered pair is 4 comma 15. Now, we're going to graph each row separately. So this is going to be our graph here. We're going to do each one of these separately. So first thing we do is we plot our 2 points. So we have 3 comma 11. So that's over 3 and up 11. 6, 7, 8, 9, 10, 11. So that's going to be right here. and we need a closed circle. So that's our starting point at 3, 11. Now, what's my next point? 4 and up 15. So here's 11, 12, 13, 14, 15. So that's going to be right about here. And that's our second point at 4, 15. And we connect them together with a line like that. And that's a closed circle there. Very important that you see. That's a closed circle, and that makes that line. Now, we need to get the other one. What about level 2 or row 2? It's pretty easy. Because row 2 is a constant function. So for row 2, whatever I plug in, I get out the number 3. So if I plug in 3, what do I get out? If I plug in 3, I get out 3. So my first point is 3, 3. Now, what do we need here for the second row? We need numbers that are what? Smaller than 3. So what's a number smaller than 3? How about 2? And if I plug in 2, what do I get out? 3. So what's my next point? 2, 3. Now this is going to make a horizontal line because that's what that is. That is a constant function. It's stuck at 3. So let's finish our graph out now. Where's my next point? My next point's at 3, 3. So that's over 3 and up 3. Now, it is going to get an open circle. Why is it going to get an open circle? Because it's here. Okay, open circle. What's my next point? 2, 3. So that's over 2 and up 3 again. Connecting them together, that makes your graph. It's done in pieces, but it's 2 lines put together. So it's just done in pieces, and this is going to be very, very similar to question 14. Now I'm going to do one like question number 15. I'm just going to change the numbers a bit, but this one is going to be like 15. Ready? Okay, I'll go on to the next one here. So this is going to be just like question number 15. And we're going to graph this one again. And I'll make up our function. Just plug some values in here just so they kind of match up with what you got in your homework here. About less than or equal to -2. How about we say between -2 and +2. And how about the last one is, let's say x is greater than or equal to 2. So this is going to be very, very similar to number 15. Different numbers is the only difference. So, where do we begin? Well, the first thing I always do is figure out open circles and closed circles. Level number 1. It's going to get a closed circle. Why? Because it is less than or equal to. Row number 2, what is it going to have? In this case, both of them are open circles, right? What about the third one? What does it get? X is greater than or equal to 2, so it gets a what? Closed circle. Now, we're going to do each level individually, and we'll put them on the same graph. So let's look at level or row number 1. Always, always begin by plugging your value in. So we plug in our value first. If I plug negative 2 into row number 1, what do I get? If I plug a negative 2 in, then I get 2 times a negative 2 squared. Watch your order of operations. Negative 2 squared is positive 4. Times that by 2, that makes it an 8. So my first point is negative 2, comma 8. Now, what do we need to make a line? 2 points. So we need 2 in each row. What does row 1 represent? It represents numbers that are smaller than a negative 2. So we need a number smaller than negative 2. So how about we use negative 3? Negative 3 is clearly smaller. So let's plug negative 3 in and see what happens here. Negative 3 squared is 9. 2 times 9 makes it now an 18. So I have negative 3, comma 18 for my second point. Let's put this on our graph. Here's my graph here. We're looking at row number 1. So plot your 2 points. We've got negative 2, positive 8. Right about here. And it gets a closed circle. Then we have a negative 3, which is back one more. And that's going to be up 18. So that's going to be clear back over here. Minus 3, comma 18. And we're going to connect these together. And it's going to make a curve. Now, why am I using a curve? Because what is row 1? Row 1 is a square, right? And a square makes a curve. So I'm going to curve them together like that. Now we do the middle. Okay, let's look at the middle. Let's now look at row 2. Plug your values in. So you always begin with that. So plug your values in and see what you get. If I plug in a negative 2, this is a constant function. In row 2, if I plug in a negative 2, I get out a 5. So my first point is negative 2, positive 5. Plug in your other value, which is x equals 2. And what is it going to be? Well, it's also going to be the same, what? 5. So what's my next ordered pair? 2, 5. This is a constant function at 5, and let's graph it real quick here. So we are at negative 2, positive 5, which is right about here. The open circle and closed circle should be right on top of each other. And that's going to be at negative 2, 5 there. And our other one is at positive 2, 5 over here, both with a open circle. Connect them together just like that. So it's a graph that has to be done in pieces. Now, this one has 3 rows, so we're going to have 3 pieces here. I know it's hard to keep it all on the screen at the same time. We'll come back to this in just a second. Let's now go on to row number 3. Okay, row 3. Plug our values in. Where do we begin? We begin by plugging in 2. So plug in the 2. So plug in x equals 2. And that's going to give you 2 minus 4, which is a minus 2. So my first point is 2 minus 2. Now, what do I need? I need a value that is bigger than 2. So next biggest number from 2 is going to be 3. So I'm going to plug a 3 in. And that's going to be 3 minus 4, which is then a minus 1. So that is now my second point, which is positive 3, negative 1. That's going to be a line. We'll go ahead and do that one here. By the way, it's going to have a closed circle here. So we're at positive 2, negative 2. So over 2, down 2. That's right there. 2, negative 2. And then we've got 3, negative 1. So that's going to be right about there. When we connect them together, it's going to make a line like that. We have a closed circle there. So move it up so we can see. This is what your graph will look like. It's done in pieces. This is curved because it's an x squared. This one's a constant function at 5. And this one's a line going up. Now, question 15 is going to look very, very similar to this. Bless you. Just different numbers is all it is. But it's very, very similar. I try to keep it almost the same. That now finishes up to 6 and 7. Next, we're going to look at 2.8. And 2.8, I think we should be able to finish it today. If we don't get it all finished today, then we'll finish it up on Tuesday. No matter what, we're going to have our exam on Thursday. So next Thursday, we'll have our third exam. So let's now go ahead and look at 2.8. And 2.8, we're going to be talking about functions. Now, how functions work is they behave just like anything else with numbers. You can add them together, you can multiply them, you can divide them, subtract them. Everything's the same. They do have one extra operation, and that's called composition, which we'll cover later on today. Or if we don't get to it, we'll cover it on Tuesday. We'll probably get to it today. But how these work is they work just like numbers. They multiply, they can add, they can subtract, they can divide. Now, one thing we have to remember is if a number's inside the parentheses, you get a number out. So that's when you have a number inside the parentheses, it gives you a number out. Variable inside the parentheses gives you a variable out. So number in, number out, variable in, variable out. These are also pretty easy to do, but a lot of times students get mixed up with that. If there's a number inside the parentheses, you get a number out. Variable inside the parentheses, you get a variable out. A lot of times, though, students get mixed up and they try to give me variables when it's supposed to be a number. So now how these work is I'm going to give you some functions and you're going to evaluate them down. So we can do addition, subtraction, multiplication, and division. So I'm going to give you two functions. We'll do numbers first. So here's what I'm going to give you. You're going to be given these two. So let's say you're given f of x equals 4x minus 3. And g of x equals x squared plus 5. I want you to find this. I want you to find f minus g of, let's say, 3. So this is what I want you to find here. Now, here's where I know what I'm going to get out. Notice there's a number inside the parentheses, Okay, so my answer has to be a number. Number in, number out. I like to rewrite this in two pieces. So I can rewrite this as, breaking it up, f of 3 minus g of 3. So notice I just split it up. It's subtraction. So I just put it in two separate ones. Now, what we do is we find each part and we plug it in. So let's start off with finding f of 3. And f of 3 would be 4 times 3 minus 3. So that's 12 minus 3, which is then a 9. So this piece is going to go, let me move it here, sorry about that. So this piece is a 3, so that's going to, sorry, 9, so that's going to go right here. So that makes that piece then a 9. Now, what about g of 3? Okay, let's do g of 3. You do them separately, and then you put them back together. G of 3 would be 3 squared plus 5, right? So that's 9 plus 5, which is then what? 14. So that goes there. So that comes down as a 14. And bring your negative down. Now we're done because 9 minus 14, 9 minus 14 makes it a negative 5. And that is your, let me write it right here, that is your f minus g of 3. So f minus g of 3 is going to be a negative 5. Do you see how I did it? Okay. Numbers in, number out. All I did was I split it up. I did each one. And I put them back together. Let's do another one. That was subtraction. I'll do multiplication next. So I'm going to change them out. Let's say you're given f of x to be 7x minus 4, and g of x to be, let's say, 3x squared plus 2x. And I want you to find f times g of negative 5. Okay, so let's take a moment to think about what we have. What do we have here? Number inside the parentheses. So what's my answer going to be? Number. That's the first thing I always do, is figure out what is my answer going to be, a number or a variable. The next ones we're going to do are going to be variables. This one, though, has a number inside the parentheses, so I'm going to get a number out. Now I'm going to rewrite this. This is multiplication as f of negative 5 times g of negative 5. So that's what I'm doing. I'm multiplying here. So we're going to multiply these together. Just like we did a moment ago, we do each one individually. So f of negative 5. Well, f of negative 5 would be 7 times a negative 5 minus 4. And that leaves you then with a negative 39. Is everyone okay with that so far? And we're going to be multiplying that by whatever we get out with g of negative 5. What does g of negative 5 look like? Well, let's try that one. Just plug in our negative 5 again. Five squared is 25, times 3 makes it 75. 2 times a negative 5 makes it negative 10. So that comes out to be 65. Now, what are we doing? We are multiplying them together. So all we now need to do is just take our numbers, multiply them together. We know our answer should be negative. So 39 times that 65. That gives you 25, 35, and it's going to be negative because one negative keeps it negative. And what is that? That is f times g of negative 5. Number in, number out. Very important that you understand that. You just do each one individually and multiply them together. Now, if there's a variable inside, then you're going to end up with a variable answer. So we'll also do addition and multiplication. And I'll also do subtraction as well. So let's do addition first. And this one's going to be pretty easy. So let's say you're given f of x to be 2x plus 5 and g of x to be 7x plus 1. I want you to find f plus g of x. Okay, so what do we know about this one? Well, this one has the variable x inside the parentheses, right? So we should end up with variables in our answer. If you remember that, numbers in, numbers out, variables in, variables out. That way you remember what your answer should look like. These are very simple. Now we rewrite. So this is going to be f of x, when I rewrite it, plus g of x. Now, what do we know about f of x? What is f of x? What is f of x given to be? It's given to be 2x plus 5, right? So f of x is 2x plus 5. What about g of x? G of x is 7x plus 1. All we have to do is add them together because they have the variable x. So we add them together. 2 and 7 makes it 9x. 5 and 1 makes it a plus 6. So that is f plus g of x. Variable in, variable out. Variable in, variable out. Let's do subtraction, just so we remember how subtraction is going to work. Subtraction is a little bit confusing because you've got the parentheses. So two new functions. Let's say you're given f of x to be x squared minus 9x and g of x to be 4x plus 1. And you can even switch the order around. How about I want you to find g minus f of x. So first thing I see, variable inside the parentheses, I better get a variable out. That's just how it works. So since there's a variable here, variables are going to come out. So what does that look like? Well, that looks like g of x minus f of x. And what is my g of x? Now I did switch the order. G is first, f is second. G of x, well, what is that? G of x, that's 4x plus 1. The negative sign comes down. Now use parentheses here, and that's going to be x squared minus 9x there. Okay, so we just bring it down. Nothing new. Distribute your negative through, and then finish it. So distributing that through, it's 4x plus 1 minus x squared. Negative and negative makes it a plus 9. So now we can rewrite this as a minus x squared. 4 and 9 makes it a 13x and a plus 1. And that is g minus f of x. variable in, variable out. One more of these, and then we'll talk about function composition and how it works. So the next ones we're going to look at are function composition. Let's see how much time we have left. Yep, go. We've got probably enough time to go through, I think, most of these. So we're going to do composition next. And here's how composition works. This is going to be said F composed with G of X. That's how it's said. Okay, this open circle here, that means composed. And when you compose functions together, you're basically going to splice them together. Okay, so it's kind of like, think about like sewing. They're going to be sewn together. They're merged together. How it's said is F composed with G of X. Now, if this would have been a 5 here, then it would be F composed with G of 5. Whatever's here is of at the end. Now, what is our definition? Here's our definition. F composed with G of X is F of G of X. That's what the definition is. And how this works is you do the inside first. So always do the inside first. Same rules are going to apply. Variable in, variable out. Number in, number out. So now we're going to do a couple of these. So let's say you're given f of x to be 4x plus 5, and g of x is how about x squared plus 3. I want you to find f composed with g of 7. So let's take a moment to think about what our answer is going to be. And I know it's simple, but a lot of times this is where students get confused. Numbers inside, number better come out for my answer. Right? 7's inside, number better come out. So rewriting, this is f of g of 7. Right? Just rewrite it. The first one goes out front, the other one goes inside. Now, what we do is we do the inside first. So what's inside here? G of 7. So let's find that. Over to the side, let's plug in G of 7. And that's going to be 7 squared plus 3, which is 49 plus 3, which is then 52. So does everyone see what I did there? G of 7, I did it over to the side. Now this gets plugged in to there. So that is now going to be f of 52, right? Because you plug in one to the other. And what does f of 52 look like? Well, f of 52 looks like 4 times 52 plus 5, and 4 times 52, that should be a 108, I believe. Oh, sorry, 208. And then we'll add 5 to that, and that makes it 213. So what's my final finished answer? Let's make sure we write it out. We know what our answer is going to be. We got it to work out to be 215. 213. So what's going to be your final answer? F composed with G of 7 is 213. There's your answer. We're going to do another one of these, and then we'll see how to do them with variables, if we have time. Yep, I think we'll still have time. So let's do another one. And again, we're just going to find the composition. So let's say you're given about f of x to be 8x plus 1 and g of x to be 4x. I want you to find, in this case, let's switch them around, g composed with f of 2. So you have to be careful with the order. Order is important here. So make sure you're careful with the order. Which one is going first? Now, g is out in front, so g comes along first. And what's inside? F of what? 2. Now, my answer should be a number, right? Because when number goes in, number comes out. Again, that's the most commonly made mistake, is students get confused as to what comes out for the answer. So what do I need to do? Well, first things first, inside is first, and let's find f of 2. What would f of 2 be? It would be 8 times 2 plus 1. So that's 16 plus 1, which is then 17. One into the other. Now, one more step left. What do we do next? We need to find g of 17. Easy enough here. So g of 17, what would that be? That would be 4 times 17. And 4 times 17 is going to be 68. So what's my final answer? G composed with f of 2 gives you out 68. Number in, number out. Now let's try this with variables. So let's do these with variables now. We'll do probably 2 or 3 of these, and then that'll be it for today. And that should be able to finish up 2.8, because we should finish right on schedule. Now, before, we have been having a number in, number out, right? So now, when we do these, they're going to have a variable in, so you get a variable out. So let's do a couple of these. So we're going to find the composition. So let's say you're given f of x to be 4x plus 9, g of x to be 8x minus 5. I want you to find f composed with g of x. So I want you to find f composed with g of x. Now, first thing I look at is what's my answer going to be? My answer is going to be a variable, right? Variable in, variable out. So I rewrite this as f out in front, g of x on the inside. Now, all this is a replacement game. So what is g of x defined to be? G of x is defined to be 8x minus 5, right? That's what it is. So I plug it in. So g goes inside. Is everyone with me so far there? Okay, so g went inside. Now, what I want you to do is we're on what? We're on now the f function. Okay, I want you to write out the f function, but leave parentheses where you see an x. So I'm going to write this out as 4 parentheses plus 9. Now, what's going to go inside of the parentheses? 8x minus 5 goes inside, right? Just write it out with parentheses for the x, and then you put your parentheses inside there. Now we can finish it. So distribute your 4 through. So 4 times 8, that makes it a 32x. 4 times a negative 5, that's a minus 20, plus 9. And that leaves us now with 32x minus 11. And what is that? That is f composed with g of x. Variable in, variable out. Let's do another one. And again, we're going to find the composition. And I'm going to make this one look very, very similar to your homework here. So how about f of x is the square root of x minus 5. And g of x is 4 over x. And I want you to find g composed with f of x. Okay, so variable in, variable out, right? It's not difficult. All we have to do is plug the pieces in. This is actually very easy as long as you're careful with how you write it. We know variable's going to come out, right? Variable in, variable out. Now, what goes first is the g. What's left inside is f of x. Okay, now, I want you to replace. What is f of x defined to be? F of x is defined to be the square root of x minus 5. So that's going in. All I did was I simply replaced f of x with what it is. It's defined to be that. Now, what does my g function look like? My g function is 4 over x. So that's 4 over, and we can use parentheses here if we need to. And what's going to go inside of our parentheses? See how it matches up? That's the square root of x minus 5. And we're going to rewrite this then as 4 over the square root of x minus 5. I'm not going to make you rationalize. You can leave it just as it is. So what would your final answer be? Let's try our final answer here. What would your final answer be? Well, g composed with f of x is going to be 4 over the square root of x minus 5. And that's it. And it looks like we have enough time for one more. So let's do one more of these. And this one's going to look like question number 9. I'll change it a bit, but pretty close. So again, find the composition. Let's say I give you f of x to be, we'll make it pretty easy. How about x squared plus 2x plus 1? g of x to be 3x minus 5. And I want you to find, again, f, oh, well, they do g, so we'll do g as well. G composed with f of x, which is g of f of x. Okay, so I'll give you a second to digest what I have here. So we're, again, finding that composition. And I want you to find g composed with f of x. So g's in front, f of x is on the inside. Now, what do? This is nothing but a replacement game. So what do we replace our f of x with? Well, our f of x is defined to be x squared plus 2x plus 1. So I just replaced it. Now we go to our g function. And I'll go ahead and pass out the sign-in sheet. This is the last question that we're going to go over. So this will be our last question here. So we now are on our g function. So I'm going to write up my g function. I'm going to put parentheses where the x is. And then what am I going to fill in? I'm going to fill that in with x squared plus 2x plus 1. All we need to now do is distribute through and clean it up. So distributing through, that's going to be 3x squared plus 6x plus 3 minus 5, which is then, when I clean it up, 3x squared plus 6x minus 2. And what is that? That is g composed with f of x. Variable in, variable out. Now, what's your homework? Well, for your homework, you should now be able to finish this packet. So for your homework, you're going to have 2.8, and you should be able to finish it, all of it. Also, on Tuesday, we're going to review. So Tuesday, we're going to review exam on Thursday. Okay, so exams on Thursday, review on Tuesday. So Tuesday, we're going to spend the class period, we're going to break up into groups, just like we've done before, and we're going to work on that practice exam. Our exam then will be on Thursday.
Can I get 2.5 through?
Yep.
I don't have one.
Yep, no problem. I've got one right here. All right. You're welcome. Sure, Chase. Yep, no problem. Okay. All right.
Oh, I did 2. I got 0 on all the 2.3 and on.
Yeah.
But I just changed it.
Yep, I'll change it.
Okay.
I just put the zeros in. That kind of gives you an estimate of where you're at. But I grade them and I put them in. I don't take off points for late work. But I put the zeros in just so you know realistically where you're at. And that kind of gets you motivated to turn things in as well.